Let's talk about Nand gates. Nand gates are just an inverted AND gate. So in an AND gate, so if we go ahead and do the truth table here for an AND, okay, the output of an AND gate is anytime both are on. So I should have a 1 when both are 1, otherwise it's all zeros. And we can see that an AND gate or a NAND gate is just an inverted AND gate. That's all it is. Okay? And we can see using De Morgan's theorem here that if we have an AND gate, if you see that, that denotes that it's a NAND gate. But an inverted AND gate is just a not X or a not Y. So we can use NAND gates as an inverter gate, or as an inverter. If we bring in one input, tie them together, and take it through a NAND gate, it inverts it. And this makes sense because if I have an AND gate and I bring in two X's, my output is a 1. If my input is a 0, my output is a 0 on an AND gate. And then if I invert that, then of course it just inverts it. So because the NAND gate is an inverted AND gate, a NAND gate is an inverter. We can also use NAND gates as an AND gate. Because a NAND gate is an inverted AND gate, all we've got to do is take the NAND gate and invert it, invert the output, and it's now an AND, right? So we can use this series, a NAND gate with the output tied together and going into another AND gate, and that gives us the logic of an AND gate. Okay? All right. And then here, finally, we're going to use a NAND gate as an OR gate. All right? So looking at De Morgan's here, we already kind of mentioned before that a NAND gate is kind of the equivalent of AND gate that's knotted its inputs, right? But here we go ahead and invert our inputs, and then we get the equivalent of an OR gate, right? If we jump back up here, let me go a little deeper into that. If we jump back up here, like I was talking about here, this is the equivalent of a NAND gate is the equivalent of an inverted inputs on an OR gate. Well, if I actually invert those inputs, then I actually get an OR gate. Okay, so a NAND gate is a gate that is called a universal gate. And of course, the reason it's called a universal gate is because I can use these combinations. This is the combination for an OR gate. This is the combination for an AND gate. And this is the combination for an inverter gate. I can use a NAND gate to produce any of my AND or inverter gates, my AOI gates, right? We're going to go, and why? So why is this so important? This is important because I can use fewer IC chips. I rarely use all the chips in my IC chip, and so this allows me to use, or all my gates rather, all my gates in my IC chips. And this allows me to do that, and we will go into that into more depth in our next video.